This video is a short explanation and demonstration of my ventilator prototype, which I'm submitting to the South African Ventilator Challenge being run by the team at Makers with Purpose. The ventilator prototype I have been working on comes from the iron lung design, which was used during the polio outbreak. And Alex Smythe in Virginia, USA, also built a version which I have learned from. It's called a negative pressure ventilator and works on changing the air pressure around a patient's lungs while they are inside an airtight chamber, but with at least their head exposed. Obviously, since the 50s, the iron lungs gave way to the more advanced positive pressure ventilators, which can also add oxygen into the air supply, and they include many other much more advanced settings than the iron lungs. However, these negative pressure versions are coming back because of coronavirus, and even 3 hospitals in the UK are urgently testing factory-made versions. So what I'm going to show you is called the Emergency Wooden Ventilator. The idea I'm working on, and many other people as well, is to see if we can design something that can be built at home with things already available or which could easily and cheaply be purchased locally. This would of course be in an extreme emergency situation when there is no other option to keep someone alive. So I took a vacuum cleaner and its pipes, some plywood, a small motor, a plastic box to simulate the patient chamber, and some other basic materials, and that's what you see here. The important part of this prototype is the rotary valve, which rotates and alternates the connection to the box with either the suction or the blowing vent of the vacuum. I've connected a motor which turns the valve, and once the air pressure is switched on, you would then have a regular cycle of alternating air pressure inside the patient chamber, which helps their lungs expand or contract, i.e. helping them to inhale or exhale. I also added a very simple manometer here to measure the pressure in the chamber, and when I turn it on just now, you should see this show a small reading. So you would have seen the pressure reading changing on this manometer here as the rotary valve was turning automatically. This means it was successfully alternating the connection from the box with either the suction or the blowing vent of the vacuum cleaner. This prototype has many limitations. Obviously, a larger, stronger patient chamber would be required. And also the rotation of the valve is too slow. It needs to be between 12 and 40 revolutions per minute, which is the same as 12 to 40 breaths per minute. Ideally, you would also use a variable speed motor so that you could dynamically adjust the breathing rate if required. Also, I had to reduce the pressure coming in to ease the friction on the valve, which is why there was a reading of only a few centimeters. When I operated it manually last week, I was able to put the full pressure on and could get about 33 centimeters on the manometer. Also, the ratio between the time for exhaling and inhaling is fixed at 2:1. This is part of the design of the rotary valve and the spacing of the holes inside. On this design, it is not possible to adjust that ratio dynamically. So that's something else that would need to be addressed or done differently. Other than that, the mechanics do work, and at the most basic level, this is a working prototype of a motorized emergency wooden ventilator. Thanks for watching, thanks for all the input, and let's hope we don't get too desperate in this crisis.